All right, today we're going to dive into some really groundbreaking AI. It's tackling a huge global problem, right? What happens when a kid's education totally depends on an internet connection that they just don't have? Well, we're going to look at a solution that works completely offline. And for millions of students, this is just their daily reality. I mean, think about it. So much of modern digital learning, it needs that constant link to the cloud. The second that connection drops, poof, the lesson just falls apart, and students get left behind. This isn't just some minor inconvenience, you guys. It's a massive gap in educational equity. So that's the big question, isn't it? That's the fundamental design challenge. How do you build technology that's powerful enough to actually transform learning, but at the same time it has to be resilient enough to work anywhere for literally anyone? It really means we have to kind of rethink our whole approach to ed tech. Okay, so to really get a handle on the solution, we've got to understand the problem first. So let's zoom in a bit on the unique challenges you see in places like rural India, where this connectivity gap is just massive. And this really all boils down to two completely different ways of thinking about it. On one hand, you've got the standard cloud-based model, right? It's totally dependent on the internet. It often uses these standardized one-size-fits-all accents that can feel pretty foreign to a lot of people. And of course, there are big privacy concerns because it's sending data off to who knows where. But on the other hand, there's this new approach, one that works completely offline, is built to understand and even preserve local accents. And this is huge. It keeps all the sensitive data right there on the device. And when you really dig in, you realize the hurdles are way more complex than just a spotty internet connection. We're talking about an incredible mix of different languages and dialects, right? A real need for content that actually reflects the local culture. And you've got tech that just fails because it wasn't built for these places. It can't understand the local accents, and it often needs super expensive hardware to even run. Okay, so with that problem laid out, let's meet the hero of our story. This is the solution that was designed from the ground up to tackle these exact challenges. It's a platform called VISTAR. Yeah, I know, that is quite a mouthful, but the full name is actually important because it tells you exactly what the system is built to do. It's all about being multilingual, hanging on to those local accents, and creating these really cool interactive visuals, especially for science and math. But let's just boil it all down. What is it really? At its heart, VISTAR is a complete learning toolkit that runs all by itself. No internet needed. That's the key takeaway here. It brings the full power of AI right into the classroom, no matter how remote that classroom is. So you're probably wondering, how does this thing actually work? How on earth do you pack all of that power into a system that can run on a simple, maybe even low-power device? Well, let's pop the hood and go inside this offline AI to see how all the pieces fit together. Okay, let's trace the path here, from a simple user input all the way to the final result. It all kicks off at the input layer. This is where a teacher or a student might give it some audio, a video, or just text. From there, it zips over to the processing layer, and honestly, this is where the magic happens. We're talking context-aware translation and native accent support. Then, the integration layer packages it all up, which leads to a real tangible output, like a fully translated lesson or a cool math visualization. And the whole point of all this? The ultimate goal? Inclusive education for everybody. And here are the core technologies, the pillars that make this whole thing work. And it's not just one thing, it's a whole suite of tools working together. You've got speech recognition that's specifically tuned for Indian accents. The translation is context-aware, which means it gets the style of teaching, not just the words. It can even read handwritten math. Yeah, handwritten, and turn it into dynamic visuals. It's just an incredibly complete toolkit. So here's a look at how that all flows logically. It doesn't matter if the input is voice or text, the system first processes it, figures out the language. Now, the really clever part is this context extraction module. It intelligently figures out what the user is actually trying to do. So if it spots a math problem, for instance, bam, it kicks on the visualization module. If it's not math, it heads over to the output engine to create the translated text or that awesome accent-preserved speech we mentioned. It's a really smart, dynamic workflow.